Hi everyone, we're going to do 7.3 now, which is the law of cosines. And so 7.3 will be its own video here. And so law of cosines is a different way to find all of the angles and sides using, instead of the law of sines, using the law of cosines. The perk of the law of cosines is that you do not have any ambiguous cases. Whatever angles and sides you get are the answers regardless. The downside is the formula is a little bit more complicated. So we use the law of cosines when we do triangles where we have given information of two sides with the angle between them, or if you just have all three sides. Either one of those, we could do the law of cosines. And so the law of cosines, if you've never seen the law of cosines, it actually is the more generic version of the Pythagorean theorem. Especially notice this last one right here. This is the Pythagorean theorem, a squared plus b squared equals c squared. But technically the full formula is a squared plus b squared minus 2 times a times b times cosine c. But on a right triangle, this c is 90 degrees and cosine of 90 is 0. That's why on a right triangle, you don't end up with any of this stuff. And you just get a squared plus b squared equals c squared. But you don't see that usually until you get into stuff like this. Any one of these formulas is worthwhile to use. The only thing you have to notice is whatever you're setting it equal to has to match the angle that you're using in cosine. The other sides, the b and the c, or the a and the c, or the a and the b, are on the right hand side. So let's see how these work. First of all, before we do an actual problem, if I was to give you just certain information, you have to tell me what the formula would use. Would you rather do the law of sines or would you rather do the law of cosines? And so this is where I would probably draw just a generic triangle. So there's your A, B, C, B, A, C. So in this first problem, I have angle A and I have side A and side B. So I have an angle and then two sides. So if you have an angle and then two sides, this is angle side side. This would be law of sines. This is actually your 7.2 ambiguous case. If I had angle A, angle B, and side C, I would have angle A, angle B, and side C. Here I have two angles with the side between them. This is angle side angle, which is the law of sines again. That is what we did back in 7.1. The last one says you have side A, probably need a different color besides green. How about purple? Side A, side B, and angle C between them. Here, this is side angle side. That's what we're doing in this section. This is law of cosines. So what I would suggest is drawing just a generic triangle, seeing what you actually have and what does that look like. Is it an angle between two sides or is it a side between two angles? And then apply which law goes with which one. So let's do this one. This says solve the triangle. Now, for some reason, there's no labels on this, so I'm going to stick my own labels here. I'm going to call this angle 121A. I'll call angle B up here at the top and angle C over there, which will make side A across from angle A. This 5 will be side C, and this 3 would be side B. So the first thing I could solve for is actually side A. Using the formula that a squared equals b squared plus c squared minus 2bc cosine A. I know everything about everything on the right-hand side of that formula. So a squared would be b, which would be 3 squared, c, which would be 5 squared, minus 2 times 3 times 5 times the cosine of 121 degrees. And much like most of these things, you're going to get a bunch of decimals and things, so we're just going to go ahead and stick it in the calculator. If you do 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 121, you'll get about 4945 or so. But keep in mind, you then have to, because that's a squared, you have to take the square root of that answer. If you rounded it off, notice all of these have no decimals on it, so if you were to take the square root and round it off to the nearest whole number, you're looking at about a being 7. So this a is 7. Now, once you get all 3 sides, you are welcome to do the law of sines at that point, because then you'll know a side across from an angle. And you can try to solve for it that way. I don't suggest doing that because you could run into an ambiguous case along the way. This one would not be an ambiguous case, but if you didn't notice that or didn't know why that's true, and you did the law of sines when you shouldn't have, you might get a wrong answer. So, and because this is the law of cosine section, I'm just going to show you how to do it with the law of cosines. So let's solve for angle B up here at the top. So the formula for angle B would be the one that starts out with b squared. And so I know all of this information except for cosine B now. So the b on the left-hand side would be 3. So I get 3 squared equals 7 squared plus c was 5 squared minus 2 times 7 times 5 times cosine B. And by the way, it's about 7.032 or so that the calculator actually spit it out, but I just rounded that off. And then so I'd get this is 9 equals 7 squared is 49. This is 25. 2 times 5 is 10 times 7 would be 70. Cosine B. So I would subtract off the 49 and the 25. Oh, my 70 quit writing for some reason. Oh, there it goes. It had a hiccup. So on the left-hand side, I'd be left with 9 minus 49 minus 25, which is negative 65. And that's equal to negative 70 times cosine B. So I'll just divide by negative 70 on both sides. So I'd get negative 65 over negative 70 equals cosine B. I would go to the calculator. Well, actually, I'd go ahead and do the inverse first. And so I'll say that angle B must have been the cosine inverse of negative 65 over negative 70, whatever that happens to be. So I'll do second cosine of 65 divided by 70. And I get about 21.78. I'll round it off to 22 since we're looking at whole numbers here for the most part. And so that angle should be 22. And then to find angle C, C would just still be 180 minus the 121 minus the 22. So 180 minus 121 minus 22 gives me 37. So there's my missing angles, the 37 degrees and the 22 degrees, and my missing side. Okay, let's do that again with another picture. Here we have 3 sides instead of an angle given. You might also notice this is an isosceles triangle. The two sides have to be the same on an isosceles triangle, so the tens match. And again, it doesn't matter what you label them. I'm going to label this one angle A, this one angle B, and this one angle C. So here I have to do what I just did on that last one trying to solve for the angles. I can't do the law of sines because I don't know any angles. But what I could do is say solve for angle A first. And so I would use the formula that the A squared equals B squared plus C squared minus 2BC cosine A. And I didn't label them the problems, but the 12 would be side A, and the 10 on the bottom would be side B, the 10 on the left would be side C. And so I would have that 12 squared equals 10 squared plus 10 squared minus 2 times 10 times 10 times cosine of the angle A. So this is 144. Oops. That's 12 squared. 10 squared is 100. So I'll have 100 plus 100. And then 10 times 10 is 100 times 2 is 200. Cosine A. Or 144 equals 200 minus 200 cosine A. Subtract the 200 from the right-hand side to the left-hand side. So I'll get 144 minus 200 equals negative 200 cosine A. So the 144 minus the 200 is negative 56. And then divide that across. So I'll get negative 56 divided by negative 200 equals cosine A. So A must have been cosine inverse of whatever that is, negative 56 over negative 200. So we go to the calculator and figure it out. So I'll do second cosine, open parentheses, and do 56 divided by 200, close that parentheses. And these are all whole numbers as well, so it's about 74 degrees-ish. So this angle had to be 74. Now, you could go through that same process again to find B or C, and then do 180 minus all the other two angles to get the third angle. Or you can kind of cheat on this one. Like for instance, I already know that this angle is 53 and this angle is 53. I know that because on an isosceles triangle, the angles that are hitting the two sides that are the same have to be the same angle. And so if you take 180 minus 74 and cut that in half, those angles have to be the same. But I'll show you that they are the same if you want to watch the next part of this video. I'm going to go through the same process again. So let's say we're solving for angle B. So I would do that. B squared equals A squared plus C squared minus 2AC cosine B. B is 10, so I got 10 squared equals 12 squared plus 10 squared minus 2 times 12 times 10 times cosine B. So I'm going to do some of this in the calculator. The 10 squared is 100 minus the 144 for the 12 squared minus the 100 for the 10 squared. This will give me a negative 144 is equal to the 2 times the 12 times the 10 is 240, so I'll have a negative 240. So negative 144 over negative 240 would have to be cosine B. Or B should be cosine inverse of negative 144 over negative 240. If I type that in the calculator, hopefully it's somewhere close to 53. Yep. And if you round it off to the nearest whole number, that is 53 degrees. And so since you have two angles, you can find the third angle. So angle C would just be 180 minus 74 minus 53, which would also come out to be 53. So if you notice it was an isosceles triangle, you could kind of cheat and jump straight to the point that, you take half of it and put each on each one. But if you didn't notice that, you could do the same law of cosines again. Okay, let's try this one. Solve the triangle using A, B, and C here. If you wanted to, you could draw the triangle. There's no triangle given here, but you could just draw just a generic triangle if you wanted to. Put the A, the B, the C on there. I know the A is 41.4. I know side A is missing, but side B is 2.78. And side C is 3.92. That way you notice this is a side angle side problem and that you can do the law of cosines. I'm going to solve for side A to begin with. So I'm going to go A squared equals B squared plus C squared minus 2BC cosine A. And since A squared is what I'm looking for, those are really easy because you can just type them in the calculator basically. You'll get 2.78 squared. That's an 8 by the way right there. Plus 3.92 squared minus 2 times 2.78 times 3.92 times the cosine of angle A, which was 41.4. Then you type it in very carefully in the calculator so that you don't mess it up anywhere along the way. 2.78 squared plus 3.92 squared minus 2 times 2.78 times 3.92 times the cosine of 41.4 gives you 6.75-ish. But remember, you have to take the square root of that. So we then take the square root on both sides to figure out what A is. So I'll take the square root of that answer to give me about 2.60 if you round it to 2 decimal places. So A would be 2.60 yards. Just like that. So I now know that this side A is 2.60. Then, whichever angle you want to solve for, I'm going to solve for angle B here at the top, doing the same process I did on the last problem. I'll use B squared equals A squared plus C squared minus 2AC cosine B. And so B was 2.78, so I'll get 2.78 squared. A is 2.60 squared. C is 3.92 squared. Minus 2 times 2.60 minus 3.92 times cosine B. And so I'm going to go ahead and rearrange this because this is a lot of decimals and things to keep up with if we go ahead and type it in the calculator at this point. So I'm going to rearrange it by leaving it 2.78 squared and subtracting off the 2.60 squared and the 3.92 squared. And then dividing that across, so I'll end up with 2.78 squared minus 2.60 squared minus 3.92 squared, all divided by a negative 2 times 2.60 times 3.92. All of that had to be cosine B. And so I'm going to rearrange it like that before I type it in the calculator. So hopefully it's a little bit easier. So 2.78 squared minus 2.60 squared minus 3.92 squared. That top part is negative 14.398. The bottom part is negative 20.384. So I could say that B is actually cosine inverse of the negative 14.398 divided by the negative 20.384. And type that in the calculator. So if I do second cosine, open parenthesis, 14.398 divided by 20.384. Rounded to one decimal place because that's what the other angle was rounded to. This comes out to be about 45.1 degrees. And then just like before, if you have two angles, you can solve the third one just by subtracting. So angle C would just be 180 minus 41.4 minus 45.1. And so we'll type that in the calculator. 180 minus 41.4 minus 45.1 gives me 93.5. And that's my missing angles and my missing side. So hopefully this isn't too bad. This is a little bit more work than the law of sines, but it's not terrible if you get it down. Okay, let's do one more of this type. Here we have angle C and side B and side A. So if you like the generic triangle I've been drawing, I'll do it again here. So C was 45.6, so this is 45.6 degrees. Side B was 8.94, side A is 7.23, and I don't know what C is on the other side. So again, this is a side angle side problem, very much like the last one, except now I'm going to be solving for C. So I'm going to use the formula C squared equals A squared plus B squared minus 2AB cosine C. So A is 7.23, B is 8.94, minus 2 times 7.23 times 8.94 times the cosine of my angle, 45.6 degrees. Since we are solving for the side, I can just type it straight in basically the way it looks. 7.23 squared plus 8.94 squared minus 2 times 7.23 times 8.94 times the cosine of 45.6 degrees. This will give me that C squared is 41.75 or so. But remember, since this is a squared here, I have to take the square root on both sides. And so if I just do square root of the answer on the calculator, I'll get 6.46 if you round it to the same two decimal places. So 6.46 meters. So this missing side here is 6.46. And then I'll solve for angle A next, doing the same process that I did on the last one. using the formula that a squared equals b squared plus c squared minus 2bc cosine a. And just like on the last one, there's a lot of decimals here, and so I'll rearrange it and then I'll type it in the calculator. But the a, let's see, a is 7.23. I'll have 7.23 squared equals b, which was 8.94 squared, and c, which was 6.46, that's what I just found, minus 2 times 8.94 times 6.46 times cosine a. And so just like I did on the last one, I'm going to rearrange it before the decimals. So I'll move some of this stuff to the left-hand side, like the 8.94 and the 6.46. And then I'll divide the stuff attached to the cosine across. And so I'll have 7.23 squared minus 8.94 squared minus 6.46 squared, all divided by negative 2 times 8.94 times 6.46 has to be cosine a. Then we'll go to the calculator. 7.23 squared minus 8.94 squared minus 6.46 squared is going to give me negative 69.3823 on the top. On the bottom, 2 times the 8.94 times the 6.46 will give me a negative 115.5048. That had to be cosine A. So A would be cosine inverse of those numbers. Just divide the 69, 38, 23 by the 115, 50, 48. And see what we get. So I'll do second cosine 69.3823 divided by 115.5048 gives me an angle of 53.1 degrees. And then once I have two of the angles, I can just do that angle B. That's the angle that I'm missing right here. Angle B is 180 minus A that I just found minus C that I started with. So angle B would be, let's see, 180 minus 53.1 minus 45.6, about 81.3 degrees. And that's my two missing angles and my missing side. Now, law of cosines is actually very important for people going into things like plan surveying, because you can usually come up with an angle based off of a surveying tool and then the distance between 2 points, and you can find the distance across something that you can't actually see across or can't measure across. Like, for instance, maybe there's a lake or a mountain in the way, a big hill, something like that. So, like in this problem, to find the distance from house A to house B, a surveyor, instead of going across the lake, measures from a distance of 40 feet from the house on the left, 90 feet from the house on the right, to get an angle of 60 degrees apart. How far apart are the two houses? So what we're looking for is we want to connect these two dots here and find this distance. That is the law of cosines. Here I would have that this distance squared is the two sides, the 40 and the, 40 and 90, not 40 and 60. 40 squared and 90 squared minus 2 times 40 times 90 times the cosine of the angle between them, which is 60 degrees. And I would just go straight to the calculator and type that in and see what I get. 40 squared plus 90 squared minus 2 times 40 times 90 times cosine of 60. By the way, cosine of 60 is 1/2, so you could do this one pretty easily by hand. So x squared should be 6,100. And then I would just take the square root of the 6,100. This is where the calculator would really come into play because you get a long decimal number here. And so your distance x would be rounded to the nearest whole number, about 78 feet. So those two houses are about 78 feet apart. And that's by using the law of cosines. One last thing that's in this section is area of a triangle again. So you could find the area of a triangle by doing 1/2 base times height, or like at the end of 7.1, we did 1/2 of 2 sides times the angle between them. Here, this is Heron's formula, Heron of Alexandria, in case you knew him. Heron's formula for the area of a triangle if you know 3 sides and you don't know any angles. Well, Heron's formula says the area is the square root of s times s minus a times s minus b times s minus c if s is 1/2 of the 3 sides added together. So I'll show you how to do the area of a triangle using this formula. So this says find the area if you have 3 sides labeled 12, 16, and 25. The first thing you have to do is find your s. So s is going to be 1/2 of those 3 sides added together. And it's okay to get a decimal here too, because we're going to be doing a lot of this stuff in the calculator anyway. So you're going to get 1/2 of 53, which is 26.5. And then the formula, the area, will be the square root of s, which is the 26.5, times the s minus a, the s minus b, and the s minus c. And so you just type all of that into the calculator and see what you get. Usually what I will do is do just the part underneath the radical. So the 26.5, that times 26.5 minus 12 times 26.5 minus 16 times 26.5 minus 25. Get that number. So this would be the same thing as the square root of 6,051.9375, and then take the square root of that. You could do it all in one step if you really wanted to. So this area comes out to be, if you rounded it to the nearest whole number, about 78 square units, whatever your units are measured in. So let's do one more. What is the approximate area of the Bermuda Triangle if the sides of the triangle are about 850 miles, 925 miles, and 1,300 miles? So you're looking for from Miami to Bermuda, and then Bermuda down to, I think, Havana maybe, or somewhere in that area, and then back up to Miami. You got to find the s first. So I would do s is 1/2 of the 3 sides added together, the 850, the 925, and the 1,300. So 850 plus 925 plus 1300 is 3075. So we're going to take half of 3075 to get 1537 and a half. Then my area would just be the square root of that number, the S, 1537.5, times, and then I just take each one of those and subtract it each side from that S value. So 1537.5 minus 850, 1537.5 minus 925, and 1537.5 minus 1300. Type all of that in the calculator and see what we get. And so if you type in all that stuff before the square root, you get a really big number. So I'm not going to write that down, and I'll just do the square root of that number to get about 392,128, or if you want to round it to the nearest mile, 129. And that would be square miles. So hopefully that makes sense. That's the end of this section. And so we have one more video to go, and we'll be done.